Good day. Today we will be looking at algebra. Now, as you can see, we have the number 3 here, and we have the letter A. Now, when we look at the term 3A, how many A's can we see here? Of course, visually, we can only see one A. It's right there. But in terms of algebra, that is very incorrect. What this stands for is that if we say A plus A plus A, that gives us a total of 3 A's. Similarly, if we said 2 plus 2 plus 2, that gives us 3 2's. Addition. A plus B cannot be further simplified as they are no like terms. However, if we look at this expression, A plus B plus B, how many A's and B's can we see? We see 2 A's, 1, 2. We see 2 B's, 1, 2. Therefore, simplifying this, we would have 2A plus 2B. And it is very important to note that when you have a number and a letter, such as the case here, this is known as a term. Now, when you have a pair of numbers and letters, a pair or more, now this is known as an expression. Just to go over that again, 2A or 2B stand alone when they are grouped together, as they are here, singularly are known as terms. Now, when you have 2A plus 2B, as we know, these are not like terms, but together they form an expression. Subtraction. Very similar concept to addition. Of course, here we are just utilizing the operations of mathematics, but with algebra. A minus B cannot be further simplified, so it remains as A minus B. Now here, however, we ask ourselves, how many A's and B's do we see after the operands have done their job? So, let us focus on the A's. 2A minus A, what does that give us? 1A. Let us focus on the B's. Positive 2B minus B, what does that leave us with? 1B. Now we move on to multiplication. As we know, for instance, 2 times 3 gives us 6. Now, 2 times 3 is the same as saying 2 brackets 3. 3 times 2 is also the same as saying 3 brackets 2. Now, when it comes to algebra, it is the exact same thing. We're just not using numbers. A times B is the same as saying A, B. B times A is the same as saying B, A. A times A is the same as saying, now here, this is very interesting. As we know, all the terms here are like. All the letters here are the same. So what we can simply do is count the letters that are the same. 1, 2. And that means A to the power of 2. Usually this is done to save mathematicians time. For instance, if we had 5 times 5 times 5 times 5. This is the same, similar concept we've used here. Alright, where we know that as they are the same, we can simply say 5 to the power, how many 5s can we see? 1, 2, 3, 4. 5 to the power of 4. Just like that. Division. Now, 2 divided by 3, we know written as a fraction is 2 over 3. Now, same thing with algebra. The A occupies the numerator spot, B occupies the denominator spot to give us A over B. Now, let us say we have an instance similar to the questions before in the multiplication, where we have a letter to the power of something. All we simply have to do when they are dividing, A to the power of 3 divided by A to the power of 1. If we cancel out 1, cancel out 3, that is the same as saying 3 minus 1 is equals to 2. And this gives us A squared. Now hold on a minute. Let us look at exactly what just happened here. A to the power of 3 divided by A is the same as saying A times A times A. All of this divided by, yes, A. Now, all we have to do is cancel out this A and 1A on top. What does this leave us with? This leaves us with A times A. And as we covered earlier in multiplication, what does this give us? This indeed does give us A squared. I hope that makes it much clearer for you. Now is the rule of thumb for mathematics. It is always good to look at questions to solidify all the concepts you have grasped. So I'll give you a couple of minutes, pause the video, look at the questions before I show you the answers. Alright, let us look at the solutions. I am more than confident these are the answers you have gotten. Thank you for joining me today, and until next time, take care.